Hello everyone, welcome to CSE Core Concepts in the series of Compiler Design. I am Dr. Sonali, and in my earlier video we have discussed about the context-free grammar, and of course we have solved some examples using the context-free grammar. So in this video also we are going to solve some more examples, so let us have some practice. And meanwhile you can also practice these examples and write me in the comment section what answers do you get, or are your answers matching with mine? So let us get started with this. So here first question is that construct a context-free grammar for a language containing the language is O to the power n, 1 to the power n, and n is greater than equal to 0. So let us say starts n with 0. So when your n is equals to 0 means you have epsilon, right? Then you have n is equals to 1. That means you have 0 and 1. So what will be your language set? So the language set will contain epsilon, of course. And if n is 1, 0, 1. Okay, if n is 2, 0, 0, 1, 1. N is 3, 0, 0, 0, 1, 1, 1. This is how the language set will go on. So what are your production rules? So production rule says S can take the form of 0, 1. And of course, it can take the multiple forms of 0, 1. So I can write S can be 0, S, 1. Okay. Or S can also be your epsilon. So here I can combine the rule and say S can be 0, S, 1, or it can be epsilon. Next, construct a context-free grammar for a language containing L, a raised to the power m, b raised to the power n. M is greater than equal to 0 and n is also greater than equals to 0. Now see here, if your m is equals to 0, n is equals to 0, right? You can have a case, right, where it is the epsilon. Then if you have m is equals to 1, n is equals to 0. So what will be your language here? M is 1, n is 0. So it will be your AB. Okay, so you can have, if your power is 0, then you can have your 1, 1, right? Not a problem. But if it is there, then it is AB. Then you can have your, you can say M is equals to, let's say 1, N is equals to 1. For that we will have, sorry, AB, yes. And M is equals to 1, N is equals to 0. What will you will have? That is A. So let us say, for example, how are you going to solve this is that S can take the form of AB. Now it is repeated, right? A raised to M will be repeated. B raised to N will be repeated. Understood? So let us take two non-terminals A and B. So where A is what? It can a repetition of A, right? Any number of times. And B can be a repetition of B any number of times. So you can have here A square, B square. So you can say A, B, B. You can say A, B, B. Understood? Because why can you say A, B, B and all is that you can have, if it is 1, M is equals to 1. Okay, N is equals to 2. Right? So you can have A, B, B. Then if it is M is equals to 2, N is equals to 1, you can have A, B and so on. So that is why we are taking two separate non-terminals. And of course, you can have when it is 0, so A can be epsilon, B can be your epsilon also, right? So if I am taking a string, let's say I am taking a string A, so can I prove it? Yes, I can say you can say S is A, B. So what is your A? Small a and B. So this I require two A's. So I can say A and B. And here I want to stop, I can use epsilon. So A and B will be B. So hence this string can be proved. Next, construct a context-free grammar for a language containing L, A raised to the power M and B raised to the power N. Now, for this, what you can do is that you have A raised to the power M, so I'm sorry, M is equals to greater than equals to 0, N is greater than equals to 1. Understood? So you can see M can start from 0, but N will start from 1. So at least there will be one B. Okay, the number of B's won't be 0. So your language set will be what? If your M is 0, there will be no A's, but there will be one B. If your M is 1, N is 1, AB. Okay, you will have one extra B. Okay, if you are saying like this. Fine. Now, how will you set the rule for this? To set the rule, you can have S is again you can take a help of two non-terminals. So your A will be what? A, okay, and A can your be epsilon also, right? Whereas in your B can be BB, right? But B can never be your epsilon. So your context-free grammar is what? You have three non-terminals here, S, A and B. Input is A and B. Understood? So here also, in this case also, you have three non-terminals for the context-free grammar, S, A, B, and you have two terminals, A and B. Then next example is construct a context-free grammar for a language containing A raised to N and B raised to the power 2N. Okay, so you can say N is greater than equals to 0. So what will be your language set? So let us say when your N is equals to epsilon, okay, then you can have N is 1, let's say. So you can have your N is 1 means 1A, and here 1 means what? B square. So you will have two B's over here, A, B, B. Now when your N is 2, you have A, but how many B's you will have? 2 to the power 2, that is 4. Okay, so the number of B's will be 2 times. So how will you frame the rule? So you can say your rule says A, B, B, right? Now you can have again this, if I want to have this string, so I can say S A, S, B, B. So if I want to prove this string and I am saying A, S, B, B. So instead of this S, I can write down A, B, B also. So A, instead of this S, I will write A, B, B and then these two B's. So done. So my rules are what? And of course S can be epsilon also. So my rule says S is A, B, B or S is A, S, B, B or epsilon. Okay. Next, let's see. Construct a context-free grammar for a language containing A 2N and B M. Both are starting with 0. And A and B will can be different. Okay. So let's say the language set is what? Epsilon. Then you can have A, B. If let's say N is 1, M is 1. Then you can have A, B, B. Let's say your N is equals to 1, M is equals to 2. So you will have A, B, B. If you have N is equals to 2, M is equals to 2. So your language set will be what? A, 2 to the power 2, right? 4. 4 A's followed by 2 B's. Okay. So what will be your grammar? So let's say A, B. Okay. No two non-terminals. So what is the least one you require? Least one is your 2 A's, right? So S is equals to 2 A's followed by multiple A's, or it can be 0 also, right? It can be epsilon also. So this is your A, sorry. And what will be your B? B is equals to, you can have at least one B or you can have epsilon. Fine. So if I want to have check for this string, how will you check? You can say A. Right. Now S is what? S is AB. Right. So A is B. So what you can expand this A more? It will be A, and B will be B, B. Now A, this will be epsilon B. If you expand this B, you will get another B. So this string is done. So I hope you understood that how the equation or the language problem can be given in the form of this type of an equation. So if you do not know what is the language set, you can replace the values N0, M0, N is equals to 1, M is equals to 1 and so on, and you can start solving, creating the language set. And once you can create the language set, you can start with the minimum values and start forming the rules. So you can also try more examples like this, and you can also try these examples and write me your answers in the comment section. So of course, in my upcoming video, we will do some more exciting compiler design problems where we are going to start with the finite automata and transition diagrams. So stay tuned and don't forget to like, share and subscribe to CSE Core Concepts. Thank you.